Hello, Tech Pros, episode 193.
Don't be so afraid to the technology developers that are out there. Don't be so afraid of the failure of a technology in order to not see the opportunities of where it can grow.
Welcome to the podcast where I chat with professionals who are getting the job done using technology 7 days a week. Each week, we start with Motivation Monday. Tuesday is about productivity, Wednesday, leadership, Thursday, technology, Friday, people and communication, Saturday, entrepreneurship, and Sunday, being unplugged. All right, let's get started. Hello, Tech Pros. This is Chad Bostic, and I'm excited to introduce my featured guest today, Brad Folkens. Happy Thursday, Brad.
Happy Thursday to you too.
Are you ready to geek out and talk technology with me?
Absolutely. It's going to be fun.
Awesome. Brad Folkens is the co-founder and CTO of CloudSight, where he oversees all technical aspects of the Image Cognition technology. He earned his Bachelor of Science in Theoretical Computer Science and Mathematics from Northern Illinois University. And prior to creating CloudSight, he co-founded CityTech USA, notable for creating the web-based collaborative government website, publicsalary.com. So, Brad, that's a really cool story that you got there. And publicsalary.com is an amazing resource for people to use, not just in technology, but pretty much across all sectors, isn't it?
It is, yeah. And it really gave me a lot of background into developing a company and also developing something, basically a platform as a service, a subscription service where, people were able to sign up dealing with customers and those sorts of things.
That's really cool. So I'm a big fan of these types of startups, right? Where you can put something together, you can pull data from all sources, and then you can create a subscription type service to it. That's an awesome model. That's a really, really cool business model.
Thanks. Yeah, it especially makes a lot of sense in the public sector. Essentially, what we did is we created this online resource for public agencies to share their wage and benefit and information. And so what happens in the public sector is they need to do that to make sure that they're paying fair wages and that they're comparable between organizations. So one city is not paying their police chief more than the next, because then, of course, the residents get involved and they get upset about it and everything else. So it made a lot of sense to put it online and to have some sort of an online collaborative tool that they could share and use. And it grew over the years. It's still out there running, but it's nice because it's a platform as a service. Everybody can log in and use it, and the members kind of it becomes sort of like an online community.
Yeah, and when you build that community, it kind of takes a life of its own, and after a while, you can kind of step back from it and say, "Hey, there's not a lot else for us to do besides just kind of make sure that the servers are up and running, make sure that the community is well taken care of." And when you have the users that are passionate and active, and they're collaborating and they're sharing all that information, that it kind of takes a life of its own, doesn't it?
It does, yeah, it does. And so what happened in parallel to developing this company is that I was doing a lot of work with my business partner in the web property development space. And so what we were doing is we were working on building a site-level search engine, which got to the point where it got so popular it became its own platform and service that many different webmasters used. So we're very passionate about this idea of search. And so in late 2011, when the eMarketer released this report that was showing that search traffic on the desktop had declined for the first time in history. And if you remember, kind of, rewind back to 2011. This is Thursday, right? So throwback Thursdays. So in 2011, we saw this up until that point, there was an increase in desktop search traffic, and everybody was happy, Google was happy, and then it started to decline for the first time in history. So that was because a lot of people were going to these mobile platforms.
Right.
And the thing about the mobile platforms is that people don't search the same way on mobile as they do on desktop. So we got really interested in this idea of mobile search, and then it kind of morphed into visual search. And we saw a tremendous opportunity in being a visual search engine, a mobile visual search engine where people could essentially search visually the same way that they were used to searching by text, by typing in a query, instead by taking a picture of whatever they were interested in. So if they're interested in like I have these speakers on my desk, if I wanted to find out where to buy them or wanted to know more information about them, I could simply take a picture of them instead of translating that in my head into a text query and typing it out. But interestingly enough, what happened was there wasn't any good image recognition technology on the market that would allow us to do such a thing. That would allow us to be able to search something, in any outside of its box, in any degree of rotational angle or lighting conditions or any of those sorts of things. The technology just didn't exist. And so we realized then in 2012 that we had to create something to always give us an answer, to give us an answer 100% of the time that was accurate and valid enough, with enough new information that the user didn't know in order to search for it online and come up with a result. And so that's how the idea of CamFind originally was born. And of course, our image recognition platform started with that. So as time went on, we started realizing that, okay, well, this is a lot more than just an app. This is a lot more than just a search app. This is an entire platform now. And it's in an entirely different class of image recognition. This is why we call it image understanding or visual cognition, in that there's a lot of history to the different types of input that you can have into a computer, right? We've got voice, and that's had a very interesting history over the past couple of decades, in fact. So when voice recognition first started, and we all remember the days of picking up the phone and sitting on IVRs and saying yes and no, and it still happens because it's a very antiquated technology.
Right.
And so this voice recognition has had an interesting past of really just not getting it. And vision is really the same. I mean, image recognition has had a very difficult and troublesome past. And in many ways, lots of providers, we still don't get it right because, if you look at the voice recognition side of things, again, it really wasn't until Siri came out where we saw the shift finally from voice recognition to voice understanding or voice cognition. And so now the difference is you can actually talk to Siri, and I mean, you can watch this in your phone, and she rewrites and figures things out as you're looking at context and additional information outside of just the activity of recognizing the words that are said. So this is really the difference between the cognition and the understanding versus just the recognition, is that there's context and there's a very rich environment of information that we can gather. It's really the difference between artificial intelligence and then just sort of like an algorithmic approach to recognition.
So Brad, I love this topic of cognitive technology that not just does stuff like on our behalf when we push a button and it does something, but it actually starts to understand and it starts to be aware. Kind of like children, right? As we're babies, we start to be aware of this shape, this round shape that's in our face all the time that we start to see over and over. That's mommy and that's daddy, right? And now we can tell the difference between a picture of a person's face and the picture of maybe a bottle, right, that we want to drink. And then over time, we start to learn more and more about our surroundings, and we as humans start to develop those neural pathways in our brains, and we start to understand and recognize, what is good and what is bad and what is some shapes or another. Let's take the technology back, because here on Technology Thursday, it's all about the past, present, and future of technology. So let's take it back, if you don't mind, Brad, to like the beginnings of image cognition. So I love your examples of how Siri works in the audio space, and how in the audio space, right, we had just very limited voice recognition and stuff like that, but it didn't really do anything. So on the image side, what I think of in the early days of image recognition technology is like OCR, right? So I put a document inside a scanner and it scans it, and maybe it creates a JPEG or a PDF along with textual information about like what's typed or written on that document. And then there's been some progression since then. But has that been like the beginnings of optical or image recognition technology, or were there other things before that?
Yeah, so there's image recognition technology has actually had a very, very, very long history. I mean, even dating back to, banks have used it for a very long time. That's exactly why the characters on a check appear the way that they do with the funny little
the maker,
the maker, exactly. And so there's been an attempt to approach this problem of image recognition from a very strictly algorithmic point of view. And the challenge with that is that none of us go off of an algorithm when we take a look at, a ball. We don't say, here's a circle, because that same circle could be a moon. It could be the bottom of a coffee cup. It could be a ball in 2 dimensions. You know, it
could be the Death Star. I mean, that's no moon.
Death Star. That's right. So, you know, there's lots of different, and so without additional context and understanding, of course, you know, we would say anything is a circle. Somebody's face might be, a circle. So it really requires a lot of additional information and a lot of processing and a lot of thought that goes behind just basically extracting the meaning behind what we're looking at. So, you know, though a lot of the algorithmic processes that were in place many, many years ago were great and they served their purpose, as, you know, time moved on and we started seeing that, you know, there's barcodes, for example, right? Barcodes is a sort of image recognition, if you think about it. It's a very simple, very basic algorithm, but it works, and it works really well. But on the flip side, as we started getting to more generic cases where we didn't have some very specific codes, you know, like the microprint is a great example on checks. And then we got beyond the microprint and we wanted to start reading, you know, the post office wanted to start reading addresses on, you know, postal notes going through the mail. We needed a much more complicated technology. And so things like OCR were born and all those things. So, you know, as technology moved forward, we expect more and more of it every day, right? So today, a lot of, you know, we saw these things like the QR codes and all that stuff, and they never really took off. And one of the reasons why is because there's a lot of friction to it. So if I have to go pull out a special app to recognize a QR code, and I can't, you know, personally read it myself, then really what's the point? So we wanted to see, you know, especially in our case with this idea of visual search, we wanted to be able to generate a response depending on the discernible detail in the image. So if we go back in more recent days, this idea of image recognition, we were seeing things like Google Goggles, where you could take a picture of something, and it was almost like the I'm feeling lucky process if you even did get a result. So, you know, you take a picture of a dog, and it would say something like, you know, carpet. I mean, it didn't really make sense for the end user. And 10% of the time was kind of the best you could get with the accuracy of Google Goggles. So this is really where the state of the art was in 2011 and 2012, and where it had gotten. And you think about the timeline of the advancement of everything with respect to computer vision. And computer vision's had a very, very long and slow past. And most of this is because computers are not intrinsically good at recognizing patterns. The human brain is one of the most amazing pattern recognizers that there is. And if we think about the difference between the processing power of a computer, algorithmic processing power of a computer, versus the algorithmic processing power of a brain, it's much, much different. It's you know, people can practice this and develop this skill, but it's very difficult for humans to process massive, massive quantities of numbers and instructions at high speeds. But it's amazing. Computers they can do that. And so there's obviously some reasons for this scientifically, but humans on the other hand, they're basically their processing frequency is very low. At one point, I read in a paper maybe like 8,000 or like 8 kilohertz, right? So it's very slow, but at the same time, we have this massive, massive ability to recognize patterns, so good that we still, in some ways, haven't been able to program computers in the same way. So it really started prompting the question. So, you know, this is still kind of the history about it. It really started prompting the question of that, okay, if we've got humans creating the algorithms to recognize images, and, you know, it's not working, basically. I mean, it's still, even as late as 2013, things still weren't working very well in the space of algorithms. How about we mimic the way that the human brain works? And so, you know, there's these devices that we can use to do this mathematically and algorithmically called deep learning neural networks. And that's really kind of where the technology started to shift.
Cool. So maybe you can dive into just the high-level topic or the high-level theory of now today as we get into, what'd you call it? I just lost it. What was this technology called?
Deep learning neural networks.
Deep learning neural networks. Okay, so what exactly, that sounds, honestly, it sounds like something out of Star Trek. So what exactly is a deep learning neural network?
Sure. So these actually have been around for a long time. These were around, I think they were developed, and all the history buffs are going to shoot me here, but I think they were developed in the late 70s, early 80s. It could have been even in theory before that, but they started resurging interest in the late 80s or beginning to late 80s. as a tool to create this sort of artificial human brain. So this was exciting for a while, and it's actually, I think, I'm sure we could all check this on Wikipedia, but it's a little bit of what provided the inspiration for the Terminator movies, because there was this excitement around these neural networks and how closely they mimic the brain. But long story short, the scientific community didn't have any very good success with it for a very long time. And one of those was because of processing power. So essentially the way these things work is the human brain is this sort of, we think of it as this infinitely complex device that's able to do incredible tasks. But in reality, it's actually very, very, very simple. There's a very simple component of the brain called the neuron that, we've all heard about, but that can be mathematically modeled inside of a computer program. So if we take a bunch of these mathematical neurons and we chain them together, we can do some very interesting things with that. Number one, we can develop a model of the human brain basically inside of a computer. But the second thing we can do is we can solve mathematically, again, because it's just a long chain of equations. So we can solve mathematically the equation of what we want on the input versus what we want on the output. And using, differential equations and some of these other things, we can start slowly adjusting the output for what it's supposed to look like given a certain set of input. And so that's basically how we train. That's deep learning. So, if you take a step back again to these neural networks and how they mimic the human brain, there's another interesting thing that happens with the human brain called neuroplasticity. So neuroplasticity is the ability for any part of the brain to learn how to do something else. So an example of this is recently they did some experiments where they taught somebody how to see. So there was somebody was blind and they taught them how to see through their tongue. So the tongue actually, they took a plate of electrodes and they stuck it on the tongue of this person and they hooked it up to a camera. And as the person started to practice and learn with it, they were able to quote unquote see through their tongue. In other experiments, they've been able to rewire the visual, so they'll take the eyes of somebody and they'll rewire them to, say, the auditory cortex. And the auditory cortex actually builds up the structures that allow it to see. So it basically morphs into what the visual cortex does, even though it's in the center of the brain called the auditory cortex. So what does this tell us? This basically tells us that there's the same basic algorithm spread all throughout the brain. And it's very simple, it's very basic, it's beautiful, but it's infinitely complex because of the massive scale of all of these equations basically chained together. So instead of having now, if you fast forward this into the technology world, what this allows us to do is this allows us to say, okay, so instead of having humans come up with these algorithms to try to recognize images, instead of having humans, experiment and really fail with being able to create these rather simple algorithms to figure out what's in an image, these formulas, let's have the computer come up with the formula. Let's have the computer come up with the algorithm to solve the problem of image recognition. And that's really where we started seeing some major improvement in the capacity of having computers being able to recognize patterns in images.
Gotcha. Okay, so I think I got a little bit of understanding on it now, Brad. It's kind of like what we're doing is we're passing in the raw data, like a picture or a photo, and then we're telling the computer what the right answer is. Instead of coding it and programming it and try to come up with what's the exact mathematical formula of a dog. Like if I could program a dog in mathematical terms, what would that formula look like? No, instead of doing that, you're saying, here's a picture of a dog. This is a dog. Okay. Here's 500 million other pictures of other dogs. Here are other dogs. Do you understand now the differences between all different types of dogs? Here are other pictures of other things, of cats, of parrots, of the sky, of the carpet, of my cup, of my computer, of my face, of the sky. And do you understand that these things are not dogs? And slowly over time, the computer itself is building this deep learning neural network inside of it. And it is going, okay, now I can recognize and understand a dog versus the sky, or a dog versus a cat, or potentially even like a Doberman Pinscher versus a German Shepherd.
Exactly. And this is how we humans learn as we grow up. If you think about, a baby, they're just starting to learn how their brain is building up these sort of structures to recognize things, patterns and movement and shapes and sounds, and linking all these things together. Now, it's interesting because a computer, we're actually just training, if you imagine learning, since you were a child, the world by shutting off all your senses and just blinking one eye for 30 milliseconds at a time. I mean, that's how we're training computers. So if we're able to do what we've done so far just with that, and then expand it to, 2 eyes, so 3-dimensional cameras now are starting to become more and more commonplace, to other senses as well, to sound, and this is really where the cognition part comes in. But still, taking it back a step, we're still at a very primitive phase, even with our ability to train computers. And so this is really what we started finding as a company, is that this is all great technology, but we really need to find a way to train the computers to learn to see, to understand what they see. And this is really sort of the critical part that we think a lot of people missed, and why a lot of previous attempts at recognizing objects in 3-dimensional space with meaning have really failed. So there's a lot going on now with deep learning neural networks. There's a lot going on with the cognition behind how these, creating something that actually understands what it sees, what it hears, the meaning behind things. There's a lot of companies now approaching this idea of AI in any different context, from virtual assistants or whatever else. But in the visual sense, we use a massive part of our brains to understand visual information. And so it only goes to show that this is not a very simple problem to solve either.
Man, yeah, it sounds very complex. So the questions that I have are around, okay, now that this technology has progressed and now that there's been a lot of thought leaders such as yourself working in this area, like what are the business problems or the opportunities in real everyday life today that we're actually solving because of the advances in the technology, right? So before, in the beginnings, we talked about how the banking industry was revolutionized and the postal industry was revolutionized because of image recognition. What are we solving today using this technology?
Well, there's the amount of applications have really multiplied tremendously to the point where this is now it's almost its own business sector. So, and I mean, I say that lightly, but, it's really true. There's just so much going on in the space of image recognition. If you look just now at cars, with autonomous driving cars, there's so much to know about the context and the surrounding visual field of when you're driving a car. There was actually just an article not too long ago about Tesla's experimentation with autonomous cars. And it really goes to show that it's not just about recognizing that there's somebody walking in front of the car, but how fast they're going, where they're going, why they're in the front of the, is it a mistake? Are they running after a child? Are they, there's so much to it. It's not just about recognizing that there's an object, within a certain proximity of the vehicle. It's really about understanding that total context, that total picture. So, and that's just one. I mean, there's many different things going on in the medical field with recognizing, having scans done and recognizing different cell structures and how they might, become or not become cancer. There's a lot going on in agriculture with robots that can go scan through fields and check diseases on plants. We're doing a lot of business with lots and lots of companies that want to understand their digital media. So there's a lot of different, and there's a lot of, it's nice because it's a very big space. I think there's a lot of area for growth and a lot of area for great competition to develop the technology in the state of the art.
Awesome. That's so exciting, all the things that are going on today. What's even more exciting to me personally is looking into the future. So we're going to do that in just a moment. But first, we're going to take a quick break and thank our sponsors. This episode of Hello Tech Pros is sponsored by Minio Cloud Storage. Minio is a cloud object storage server for developers and DevOps written in Go. The Go programming language is the emerging language of choice for modern cloud infrastructure projects, and it allows Minio to be highly concurrent and lightweight. Minio is Amazon S3 compatible, built with microstorage architecture in mind, but at its heart, Minio is simple, scalable, and supported by a passionate developer and user community. In episode 89 of Hello Tech Pros, I talked with A.B. Periasamy, one of the founders of Minio, about the importance of community support and recruiting software developers who are as passionate about their product's code as artists are of their art. Check out that episode at hellotechpros.com/89 and check out Minio Cloud Storage at minio.io. That's minio.io. Are you new to podcasting? Are you looking for a fast, high-quality, yet budget-friendly podcast production team? Let TransSource Media take care of you. With a team of professional audio and video editors, writers, and graphic artists, they can help you build your podcast from planning, post-production, and platform submission. Using only cutting-edge software and studio equipment, they're here to make each and every show sound at its best. To get a free quote, please visit www.transsourcemedia.com or send them an email at marketing@transsourcemedia.com or call them at 209-505-5693. TransSource Media, transforming businesses through the power of multimedia. Okay, we're back with Brad Folkens. Brad is the co-founder and CTO of CloudSight, and we've been talking to Brad about the past and the present of image cognition technology. And what that is, basically, from my little pea-brained understanding of it, is, you know what, we're not just teaching a computer to do the mathematical formulas and discover that this is black or brown or red or blue, or that this is a triangle or a square or a circle, but we're really trying to teach the computer to understand exactly the context around the shape or this picture that we're showing it. We want computers to have more understanding. So, for instance, as we're developing our autonomous cars, right, the autonomous car can see the road around us and see that we're driving at night, you know, and in the back roads of Panhandle of Oklahoma, where I've made many drives in the past, and it sees, hey, there's an object that looks like a deer on the side of the road. Now, it's not in my range, and we're not going to impact it. But what we need to get to is understanding that we're not safe just because the deer is on the side of the road, because any split second that deer could jump in front of us. So we need to be aware that this deer has a mind of its own and it could potentially jump out, and we need to be ready for it. So, Brad, as we think about the future of this technology, the future of image cognition technology, what do you see coming down the pipe, either in the short term or the long term, that we can get excited about?
Well, I think what is really exciting about this idea of visual cognition is that it plays very closely into artificial intelligence. So, you know, as we look to the future, we all have really been excited about, especially in the scientific community, about this idea of artificial intelligence. What will it do? What can it possibly do for us? You know, in the very basic sense, if we look at the things like the virtual assistants, what if Siri could see? What if you could say something to Siri of, you know, oh, what is this? And she says, okay, let me see that. You know, what if you could ask Siri about some rash that you have on your arm, and you could go back and forth with her a little bit, and she could maybe even diagnose it, if that, you know, legal reasons aside. Mm-hmm. But there's a lot we can do with visual just in the short term, but looking out further in the long term. Your example of the autonomous cars is a perfect example. Because, you know, in this case, there's so much cognitive processing that goes on in our own brains of trying to make predictions of what could and couldn't happen given situations. And, you know, we see these things a lot of times as instinct. But the reality is our brains are these massive parallel processors that are able to recognize these patterns in ways that we haven't been able to with computers before. So, you know, if we look into the future, we could say, okay, well, with enough artificial intelligence and with enough visual understanding, could we predict if that deer could come out into the road? Could we predict if a cancer cell will begin to start to become malignant years before it ever does? Can we actually just look at how a person is behaving to see if they may be sick, to help them out ahead of time? Can we see if, based on a certain crowd, you know, there's a lot of things going on in with terrorism right now. Could we see, based on certain behaviors in a crowd, is there somebody that is suspicious in that crowd? Do we need to identify them? Do we need to potentially, get them in for questioning, or should we look at additional things? So the visual understanding and processing of a scene, of an image, of a video, is something that is definitely going to progress very quickly, I think, as we start to tie this into AI, as we start to tie this into the general understanding, whether it be virtual assistants or autonomous cars or in terms of defense or anything else. But it's amazing to see what we've seen as a platform provider is a lot of many different ideas coming together. We see developers from many different practices and industries utilizing image cognition to solve very important problems. Some of them I mentioned before, but as time goes on, we just expect the type of creativity to really bloom, because there's when you think about a computer and the types of things that it can do, the possibilities are really endless. And especially when we start to look at artificial intelligence. There's an interesting movie that explored what artificial intelligence could be in the future, this Ex Machina that came out last year. Mm-hmm. If I'm saying that right, people always correct me on that. But a very important part, if you watch the movie, a very important part to how these machines become and act like humans is this visual understanding, is being able to understand the world around them and understand what's going on and cognitively process that. And so we really are the ones that want to provide the vision, the visual understanding to artificial intelligence.
Yeah, that's such a fascinating groups of topics. It's just, can the artificial intelligence with image recognition kind of tied into it, cognitive image recognition, right? Could it do things like you said, like stop a terrorist or identify suspicious behavior? Or if we brought someone in for questioning, could we point Siri at it and interview this person and say if they're telling the truth or not, right? So police officers are trained to look for little visual clues and can tell, hey, his eyes are dilating, not dilating. Someday there will be an app on my phone, or worse, on my wife's phone, and she will pull it out and she will say, Siri, is my husband telling the truth? And then she'll point it at me and ask me a series of questions, and I'll get very nervous and I'll start sweating, and Siri will say, yes, Shauna, actually Chad is telling the truth, but he's probably holding back at least 10% and not telling you everything that's involved. So it's very exciting and very scary at the same time of where this technology is headed.
It is, yeah. It is very exciting and it is very scary. And I think a lot of that will be fleshed out over the future years. Certainly any technology can be exciting or scary, but I think there's a lot of amazing, promising things to this in the coming near future and far future. But that's a great idea for an app. Actually, I hope one of our developers that signed on to the platform starts to experiment. It was about to see a bunch of pictures of your face in a row, and maybe perhaps detect whether or not you bought that iPhone 7 last week. And
yeah, full transparency, right? So if you always live in a world of complete transparency and you're open and honest with your spouse, then you have no fear of them pulling out the cognitive recognition is he lying app.com that some of our listeners or some of the people working with Brad may be developing. So just always be honest and you don't have to worry about that. Brad, before we wrap this up, can you share any parting words of wisdom for our audience, and then the best way that we can get a hold of you, and then we'll say goodbye?
Great. That sounds good. Yeah, no, there's so many, it's funny. I'm asked this all the time as an entrepreneur, and there's really so many different things that I've learned over the years through both the successes and the failures. But I definitely think, especially with respect to technology, don't be so afraid, to the technology developers that are out there. Don't be so afraid of the failure of a technology in order to not see the opportunities of where it can grow. I mean, when we were first developing this technology, we were really disappointed at what was out there in terms of image recognition. But what we really started to learn is, oh my gosh, this is a tremendous opportunity to develop something that can cognitively understand what's going on in visual content. And it's amazing. I mean, that's really where the idea of the platform was born. So, sometimes as technologists, we can say like, well, it's technology, they can't do that. But reality is that's an amazing opportunity for something new, something different, something outside of the box that nobody's thought of before.
Awesome. Brad, thank you so much for joining me on Hello Tech Pros today. You know what, dude? You have inspired me and motivated me to get super, super excited about this technology because kind of going back to the Star Trek reference earlier, one of the things that I always loved in that show was the holodeck, right? And we've got so many different things with virtual reality and holograms and all that technology. But now one of the key missing components that we don't talk about when we talk about, well, when I say we talk about it, I mean the people inside my head that talk to me. Anyway, what we don't talk about is how the holodeck actually needs to recognize what I'm doing inside the holodeck so that the environment can change and shift to react or interact with what I'm doing. And so that makes me even more excited that someday soon we're going to have it in a holodeck where I can play and have some amazing adventures. So I really appreciate you coming on the show and sharing this information with me.
Thanks a lot, Chad. Really appreciate it. Yeah, it was fun.
Awesome. Tech Pros, if you are working in this field of image cognition technology, you're amazing. You're a rock star. And the one thing that I would advise you to do is, not work on that Siri app that's going to tell whether or not the husband's telling the truth. Work on the holodeck thing because that's where the money is. That's where you need to be focused. You've been listening to Brad Folkens, and I'm Chad Bostic. And until next time, take care. The show notes page for this episode can be found at hellotechpros.com/193. Do you use Slack for team communication? Join the Hello Tech Pros Slack channel at hellotechpros.com/Slack. If you enjoyed this episode, please leave a review, subscribe to this channel, and check back tomorrow. This has been Technology Thursday, but tomorrow my featured guest and I discuss people and communication. On Saturday, we talk entrepreneurship, Sunday, being unplugged, Monday, motivation, Tuesday, productivity, Wednesday, leadership, and back again on Thursday to discuss technology once again. And I'll talk to you tomorrow.